Welcome to Spring LIB.
Hello everyone, today we're doing chapter 11, problem 60, and this problem asks us to generate these two products, A and B, using only this starting material, this organic starting material in the process. So what we have is we need to start with this 1,2,3 OH, so we need to start with this alcohol starting material, and we need to somehow oxidize this to an alkyne with addition of carbon. So we can say that in our product A, we want 1, 2, 3. So 1, 2, 3. So we have 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6. And we need to retrosynthesize this from the starting material. So let's break it down to how we can go about generating something like this. So we know we need to add some carbon. So right now we only have 3 carbons, and we need to add an extra 3. So we know that if we were to break apart this acetyl or this alkyne, if we were to break this apart, then we could get something that has 3 carbons and then something that also has 3 carbons. So this has, let me draw something that has 3 carbons with 3 carbons. So we have this alkyne here with this acidic proton that can be deprotonated to make a carb anion that can act as a nucleophile, and this nucleophile can attack electrophilic alkyl halide with 3 carbons and a leaving group. For example, we can say bromine. So this is probably going to be the last step. So from this alkyne, we were going to nucleophilically attack this alkyl halide to kick off our halide being bromine to give our final product. So this is going to be the last step when we go in the correct direction. But now, how can we generate these two components? Well, our starting material has 3 carbons, and each of these components also has 3 carbons. So let's start with the easier one. So how do we get a halide, specifically bromine or chlorine, from an alcohol? Well, working backwards, we know that we can get this 3 carbons from our starting material by using PBr3. And remember, if, for example, instead of bromine it was chlorine, then I could use SOCl, so SOCl2, or SOCO3, sorry. So now we know how to get this starting material or this intermediate from our starting material using PBr3, but how do we get this from this? So let's first oxidize this to an alkene, so the one-level oxidation. So we know we can oxidize this by using some sort of strong acid. So we can just use H3O+. So what that will do, will protonate this to protonated water, if you guys remember. And now this wants to leave, but in order to leave, you need to do 2 things. Well, this alcohol got protonated to water by picking up a proton from here. So now we have H2O, so the conjugate base of our acid catalyst. But now we need to reform our acid catalyst. So this H2O needs to pick up a proton. So it can pick up this proton to reform H3O+, at the same time form our alkene. Now from an alkene, we need to go to an alkyne. So we've done this before in previous examples. So if we add diatomic halide, we know that we will get addition on either side, the halide. And then if I add some sort of base, 2 equivalents of base actually, so 2 NH2, for example, just like in previous examples. So this is everything we've done already in previous examples. This is why I'm moving pretty fast. So we make a new bond. When you make a bond, you break a bond, making a new bond. When you make a bond, you break a bond. So your halide falls out, and you're going to do this 2 times. You'll pick up this proton now, make a bond, kick off this bromine, and then guess what? You made your final intermediate here to get to this step. So overall, let's write this nicely. So overall, we're going to start with this product. We're going to add acidic water to get an alkene. From alkene, we're going to add a diatomic halide, so it can be Br2Cl2, anything but diatomic, to get trans addition across And then we're going to add some sort of base. So I'll write the actual salt version of it this time. And we need 2 equivalents. So 2 equivalents to get now this starting material. Now from here, we need to react it with this. But how do we get this product from this? Well, we took that starting material, we added PBr3 to get our alkyl halide, which acts as an electrophile. But how do we make this into a nucleophile? Well, we need to deprotonate this acidic proton to make a carbon ion using sodium hydride, and then next we'll add our electrophile. And now we get 1, 2, 3 carbon addition to get A. So now let's get B. So from B, let's see. B, we have this. Let me draw it on another page. So in B, we need to start from this and get somehow to so let me just count my carbons. 1, 2, 3. So the alcohol is coming off this carbon, if I remember. Yeah. So this is a little bit more tricky. So how we can do this is, so we know that we need to form an alkyne. So we already know how to form this alkyne, these 3 carbon alkyne. So let's break this alkyne bond. So we already know how to form this. So we know how to form this through this synthetic scheme to the step. Oh. So this synthetic scheme from here to here. So we know how to form our alkyne. And then from our alkyne, what do we need to add? Well, we need to add 1, 2, 3 more carbons. So from this 3 carbons, how we can think is, so now this is broken up to this alkyne, which we know how to form. And then we need to add it to this. So it has 3 carbons with the central alcohol, secondary alcohol. So how can we form this? Well, we know that we need to start from our starting material being this. So we also know that if you want to change this primary alcohol to a secondary alcohol, the easiest route that I can think of is to make this into an alkene, then add the alcohol using Markovnikov's addition. So then you would get your carbocation on your central carbon, and then you would get the alcohol neutralizing carbocation to get the secondary alcohol. So from here, we know that we've already made an alkene. So how do we make the alkene? Well, from the very first step of the synthetic scheme, so if you add H3O plus, we form this alkene. And now, the thing is now, if I just add a secondary carbon, then how do I make this into a into electrophile? Because I know that I can deprotonate my alkyne to make it into a nucleophile, to nucleophilically attack my electrophile somewhere. But how do I make this into an electrophile? Well, if you remember, how do we make epoxides? So if I were to have some sort of, let me arbitrarily write this. So I have 3 carbons, so 1, 2, 3. I have my central alcohol. And now on either side, right adjacent, if I have a halide, I know that I can have epoxide ring formation. So remember, if you have an epoxide ring formation, then you have something like this. And now your nucleophile will attack on the least sterically hindered side. So the least sterically hindered side is the side with more number of protons. So this is the side with more number of protons. So we know that this nucleophile, in essence, can attack this electrophile, making a bond and popping that open. So this is essentially the electrophile that we need to generate. So how can we generate this electrophile from this? Well, we just oxidize this to an alkene. So from an alkene, how can I get this hydrogen halide component here? Well, we know from previous examples, if I add my diatomic halide with water, then I can have some sort of alcohol addition to my most substituted carbon being in the middle with the halide being out here. So let's draw how that would work. So you would get some sort of Markovnikov's addition with the chlorine being added to the least sterically hindered side. And then you have a secondary carbocation, which water can neutralize. Then you have something like this, protonated water, but then you also have Cl-, which can pick up one of these protons to neutralize your water. And this is exactly what I needed here. And this can undergo deprotonation. So if I make this into a stronger nucleophile to help drive this reaction forward, so let's say I use sodium hydride to make O-, then I know that this reaction that I drew up here will go to progression, to completion, to form now my electrophile. Now if I take this electrophile and add it to my nucleophile here, I can get my final product. So let's draw out all the steps neatly. So we know first we need two components. We need this component and we need this component. So we need 1 and we need 2. So we draw how we already went through how to get 2. So from the starting material, this is how we get our electrophile. But how do we get our nucleophile? Well, we already did that in part 1. So now if I just redraw everything from part 1, if I redraw that, then now I have my electrophile. I'm going to react it with my nucleophile, but I need to deprotonate this, so I'm going to need sodium hydride. So I'm going to sodium hydrate to deprotonate my nucleophile. So I'm going to attack this, and then remember it's going to attack on this carbon being the least sterically bulky carbon, so it's going to attack on this carbon. So then I would have an O-, because remember when you make a bond, you break a bond. So then we would get 2 electrons on oxygen, but we need an alcohol. So then step 2 is we need to add water to neutralize everything. So then we instead of O-, we get an OH. And that's exactly the product that we receive in B.